Okay, so today we're going to do 3-4, which is all about perpendicular lines. And the first thing we're going to talk about today is a perpendicular bisector. Hey, remember that term bisector? We've talked about segment bisectors. We've also talked about angle bisectors. Whenever we had a bisector, Xavier, what did the bisector do?
Cut an angle in half.
Yeah, so the angle one cut the angle right in half. The segment bisector cut the segment in half. So a perpendicular bisector of a segment is going to cut the segment in half, and because it's perpendicular, it's going to form a 90-degree angle. Okay, so before when we did the bisectors, it did not have to be perpendicular. For example, you could have had a bisector like this, right, that still cut it in half. But the perpendicular bisector, and you should draw a picture just like I have one here, not only is going to cut your segment in half, well, actually it's a segment, so I'm going to put this, but it's going to form 90-degree angles. And then I just called this A, and this is B. And why did I call this M? Yeah, if it cuts it in half, then it's going to be the midpoint. Okay, and then the next thing we need to know is that the shortest segment from a point to a line is perpendicular to the line. Okay, so the shortest segment from a point to a line is perpendicular to the line. So for the next couple, I'm going to give you a drawing, and you are going to name the shortest segment from A to BC. And then we're also going to write and solve an inequality for x. Okay, so we're going to do that part together. All right, so if you have a straight edge, you guys can get that out for your drawing. Guys, that does not require a conversation. I need you to stay focused on what we're doing. So we're going to start by drawing a line, and then we are going to be drawing a triangle. Okay, and then if we see this little square, we know that means it's a right angle. This triangle is going to be A, B, C. And then you're given that AC is 12. And then AB is going to be x minus 5. Okay, so the first thing it says is name the shortest segment from A to BC. Well, we just talked about the shortest segment from a point to a line is going to be perpendicular to the line. So, Ella, based on this drawing, which segment is perpendicular to our line?
AB.
AB, right? And you really had two choices. It was either AC or AB. The shortest segment is always going to be perpendicular, so we know that it's going to be AB. Okay, and then we'll just say because AB is perpendicular to BC. Okay, and then part B says to write an inequality inequality and solve for x. Okay, so when you're writing an inequality, that's when you're going to have the less than symbol, the greater than, less than equal to, greater than equal to. If we know that AB is the shortest segment, we can say that AB is going to be less than the length of AC. Okay, because AB is the shortest length from A to BC. So if this is the shortest length from A to BC, that means that this length from A to BC is going to be greater than. Okay, so there are two different segments. AB is less than AC. All right, so then let's plug in what we know. So AB, Matthew, what's the expression that we gave to AB?
X minus 5.
Okay, good. So we're going to have x minus 5 is less than what? 12. Okay, so AB is x minus 5, AC is going to be 12, so x minus 5 is less than 12. It says write an inequality, so this is going to be your inequality. And then you are going to solve your inequality. So remember, when you're solving inequalities, it's the same rules with an equal sign. There's only one special rule. Do you guys remember what it is? The one special rule?
If you subtract to another side,
Nope. If you divide by a negative,
then you flip the sign.
then the sign flips. Okay, so if you divide by a negative, then the sign flips. So all we're doing here is we're just adding 5. So we are just going to treat it just like it was an equal sign, which means my x value is going to be less than 17. Okay, so my x value is just going to be less than 17. Okay, now if you think about this, if you were to plug 17 back in, what's 17 minus 5? 12. So I know it has to be less than that because I don't want it to be equal to 12. If it was something like 16, 16 minus 5 would be 11, and 11 would be less than 12, and we know that that segment is shorter. Okay? All right, the next thing we're going to do is go over the theorem. So when we go over theorems, you will need a highlighter, and we are going to annotate the important parts of those theorems. Okay, so the first one says, if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So let's talk about what that means. So if they form a linear pair means that they're going to add up to what? 180. Okay, if the angles are congruent, that means that the measures are the same or equal. Okay, so the measures are equal. It says then the lines are perpendicular. So if they're perpendicular, what do they form?
Right angle.
Right angle. Okay, now if you wanted to use that theorem on a proof, this is what you could say. Two intersecting lines form a linear pair of congruent angles. The lines are perpendicular. Okay, so in this diagram, what they're saying is if they have to add up to 180, but they have to be equal at the same time, the only way that's going to happen is if they're 90-degree angles. And if they're 90-degree angles, that means that the lines are perpendicular. Okay, so this means just that the lines are perpendicular. Okay, let's work our way through the next one, which is the perpendicular transversal theorem.
Plus,
Guys, you can say it quietly. You don't have to interrupt the whole lesson. So perpendicular transversal theorem is what we're talking about next. So in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Okay, so if you're going to use this in one of your proofs, you can just say the perpendicular transversal theorem. Okay, so that says if a transversal is perpendicular to one of two parallel lines, then it's going to be perpendicular to the other line. And then so that would be your Q and P. Let's talk about kind of how that works. So we're actually going to draw another little diagram. So let's think about it this way. If you know that these two lines are parallel, so you know that P and N are parallel to each other. This is P and this is N. Then you're going to have a lot of special angle types. Do you guys remember the angle types we talked about a few days ago? Okay, so, yep, alternate exterior, alternate interior, corresponding. Okay, so the one that was labeled was this angle here. Okay, so this angle would be corresponding to this angle. So if you have a right angle here, this one has to be a right angle because corresponding angles are what? Yeah. So corresponding angles are congruent. So if this is a 90-degree angle, because these are parallel, this one also has to be a 90-degree angle, which means that Q is also perpendicular to P. Notice that it just says Q is perpendicular to P. It doesn't say N is perpendicular to Q. That's something that would already be understood. Okay, so you would have already that Q is perpendicular to N, and then your conclusion would be that Q is perpendicular to P. Okay, and then if it's a 90-degree angle, then it's going to form perpendicular lines. All right, let's look at the last one. So if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So if two lines are perpendicular to the same line, then the two lines are parallel. Can you guys think about what reason would lead to that? What is it? Yeah, so we know that's true by the converse of the corresponding angles postulate. Right? Because if corresponding angles are congruent, then we know that the lines are parallel. Okay, so do you guys see how that ties in with some of the things that we've been doing already? So we're just taking them a step further with our perpendicular lines here. All right, then what do we like to use theorems for? Proofs. Yay. Okay, so you guys have a diagram, and you also have a given statement and a proof statement. Okay, so we're going to start out with just one of our given statements. So angle EHF would be be congruent to angle HFG. And that would be given. Okay, so whenever I write that down on my statements and my reasons on my actual proof, I also like to mark it off in my diagram to help me get a better picture of what's going on. So if EHF, oh, we should have a line there. Did you guys not have one either? It looks like I drew one in. So we're just gonna draw this one here. Okay, so angle EHF, which would be this angle here, is congruent to HFG, which would be this angle here. Those kind of look like what kind of angles? Yeah, can you guys see that those look like alternate interior angles? And if alternate interior angles are congruent, we can say what? Lines are parallel. So let's talk about what lines are parallel. Okay, so we do have alternate interior angles. Remember, alternate interior angles are going to make some kind of like Z here. So the alternate interior angles have to be on the two lines that are parallel. So the two lines that are going to be parallel are going to be EH and FG. And because they don't have like another name, we do have to label them as EH. So the line EH would be parallel to the line FG. So we already talked about why. We said we knew these were parallel because these angles are what?
Alternate interior.
Yep. Okay, so then what would be our reason?
Converse of alternate interior angles.
Okay, so the converse, right? Because the converse is what proves the lines are parallel. So this is going to be the converse of the alternate interior angles theorem. Okay, well we have to put in our other given statement, which is that FH is perpendicular to GH, and we're going to put our arrow symbols in there. And that is going to be given. And then we also know our last step has to be what we're going to prove. And that's that EH is perpendicular to GH. So if it's given that FH is perpendicular to GH, I do already have that marked off here, but I am just going to do it again. Your FH is perpendicular to GH. We have to say why EH would be perpendicular to GH. Okay, so what do we think? If FH is perpendicular to GH,
Would it be transitive?
no, it'll be something new that we talked about today. Okay, so see how both of these are perpendicular to the same line?
Oh.
Yeah, it'd be the perpendicular transversal theorem. So let's look back at that, your perpendicular transversal theorem. So if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Okay, so this was our transversal. Okay, so our transversal FH, they said that that was perpendicular, okay, to GH. So if the transversal is perpendicular to one of those parallel lines, it is also going to be perpendicular to the other. And so that'll be your perpendicular transversal theorem. Okay, so your homework today is going to be a couple of different things that I'm going to let you work on. So you are going to have a worksheet, and then you are also going to be doing a construction of parallel lines activity, which is from page 179 in your textbook. So I want you to do the page 179 first, and it is the perpendicular lines activity. Okay, and your 3.4 worksheets. Okay, so I'm going to give you all of those, and then I'm going to give you the rest of today to work on them.